Morning, everyone. Let's get started. Okay, in yesterday's session, we understood why SQL is needed to get the data from the different sources, right? So you may be using any of the reporting tools here, but if you want to extract the data from the database to report using any of these reporting tools, then you need a common language to interact with the databases, which is SQL, Structured Query Language. So probably a few would have worked with Excel, a few would have worked with, Power BI. If you want to get some data, definitely you need to learn SQL in order to interact with any kind of a database. Okay. So if it is like a, a CSV file, directly you can read it, or a PDF file, you can read it. But if it is from a database, you need to learn this. Okay. It's not that every time we write the SQL queries, but definitely we all need to have some idea about the SQL and the any kind of RDBMS, any database system. So the reason being, once you get into a bigger company, there you don't see the data inside Excel files. Inside a database you see. So that means you need to understand what is a table, what is a view, how the relationships are created, what are the keys and constraints. Okay. So for that, I'll just take you through step by step. Right. Yesterday we were talking about this, like why should I learn this? Because you as a reporting analyst or a data analyst, you know the requirement well, and you can write a better query, right? And most of the complex functions can be implemented simply in SQL queries. And also, we can easily understand the data modeling concepts inside Power BI, Tableau, or ClickView or ClickSense once we learn SQL. See, most of the participants have this question like, Excel is also kind of a database only, right? Where I can store some data. But understand, any place where we store the data, we can call it as database, no doubt about it. But when it comes to SQL kind of a database, right, it is RDBMS, the database management system, where the data is stored in the tables that are related. So we'll go through one by one, step by step. But what is a database? Any collection of related information is a database. It can be stored inside Excel. It can be stored inside any other place where you have some tables, okay? But Excel is not a database application. Of course, it can store the data. There is no server for Excel, okay? It's just simply a file. Inside the file, we can store the data. But when it comes to an actual database, where you need to have a server also. We'll talk about what is a server, what is a client, what is a database, okay? How to use the server to interact with the different databases. We'll see that, okay? So any collection of related information is a database. It could be anything. It could be a phone book. Yes, it is a database. But where are these databases stored? Where can they be stored, right? A database can be stored on a paper. On a paper, you can write it and store. You can consider that as a database. In your mind, yeah, our mind is our database, right? So much of data we can store there. On a computer, this is recommended. Why? Because computers have the storage devices. It could be SSD, HDD, or any other kind of a drive. You can store so much of information there without missing anything, right? So we prefer computers to store the databases. Okay. So what is a database? It's a collection of data objects used to store and manage data. It includes tables, views, procedures, triggers, indexes, and so many other things. So basically, what is it? It's a collection of data objects. What these objects do, they store and manage data. Okay. Collection of data objects, you can say simply. Right. So when it comes to a database, you can store the data inside Excel. You can consider that as a database. CSV, yes, you can consider that as a database. But when it comes to the last three, MS Access, SQL Server database, or Oracle databases, these are RDBMS, relational databases. Okay. So what is a relational database? I'll explain it shortly, but these are two things, simply files. These are files actually. Files also can store some data, but databases are designed to manage and store data. And moreover, these are scalable options. You can expand them as per your requirement. A few of the databases, of course, Access, you cannot expand. It has a capacity up to 2 GB database size. But other things like SQL Server databases, Oracle databases, you can expand them. Okay, size of it. Right. What is a database? For now, you just remember that some place where we store the data. That's it. It's a database. And then you get a question. What is SQL then? Database is the place where we store the data. Okay, these are the different data objects and where we store the data and we manage the data. Then what is SQL? SQL, it's pronounced as SQL. SQL, okay, stands for Structured Query Language. And this is the common language that we use to talk to the database server. Right? Yesterday, I told you one example, like in a restaurant, we have a server. So who serves the food, right? And you can talk to that server in which language? In a commonly understandable language. You cannot use, you go to a Hyderabad restaurant and you can, let's say if you start speaking in Spanish, person may not be able to understand. That means you as a client or a customer, you need to talk to the server in a common language. That language is SQL. Once that server understands your requirement, let's say you want to place an order for food, then you can give instruction to the server that I want this, I want this, I want this. Then the server goes to the kitchen and gets us the food, right? So basically here also it's the same thing. You need to talk to your server in a common language, which is structured query language. There are different variants in structured query language. We'll talk about that. So understand that SQL, it's structured query language. It's a common language. It is used to communicate with the database, right? And it's a media through which we can store and read the data from a relational database. And again, we have a question. What is SQL and what is SQL Server? Most of the places you see this SQL Server, right? We are learning a language here. Okay, here we go. SQL is a language. Server is a server application, which is basically from Microsoft. It is Microsoft SQL Server. Yesterday, we discussed this. We as a client, we talk to the server in which language? In SQL language. And what is that server name? Microsoft SQL Server. Let's talk about the same restaurant example, right? Yesterday, we were talking about this. You go to a restaurant. That's your entire database environment, okay? Where you have a server. What is that server name? Microsoft SQL Server. That is a server name. And you as a client, and you talk to that server in which language? SQL language. What is SQL? Structured Query Language, right? Don't get confused. They are not same. SQL is a language. Microsoft SQL Server is a server application, right? You talk to the server using SQL language, okay? You have from, other companies also, Oracle servers you have, IBM servers you have, MySQL servers you have, right? Different servers are there, different names. Let's say if you are looking at a database environment, there are different servers and each one of those, let's say servers have different names, right? You have Microsoft SQL Server, you have Oracle servers, you have IBM servers, you have MySQL servers, okay? Different types of servers you have. And for all of them, what is the most common language that we use? SQL. structured query language. It's a language and we interact with the servers using this language. Yesterday we discussed, right? In a Hyderabad restaurant, what is that you speak? A common language. It could be either, Telugu, Hindi or English, right? Similarly, to talk to these servers, what is the language that you need? You need SQL. But here we go. You need to use different variants of SQL. Okay. So to talk to these servers, we need different variants. What are they? You have here for Microsoft SQL Server, we have a language called TSQL, Transact SQL. TSQL. The variant of SQL we are going to use is TSQL. Okay, what is our server name? Microsoft SQL Server. What is the variant of, okay, which language we use? SQL. To be specific, which variant of SQL are we going to use? TSQL, Transact SQL, and which is meant for the Microsoft SQL Server. Okay, so you can talk to that server using TSQL, Transact SQL. Okay, fine then. So what if I'm let's say I'm a client and I want to talk to my server in TSQL. That means I need to type this code, right? This TSQL language, I need to type it. Of course, I'll also include how you can take the help of ChatGPT or any other AI model to generate the SQL queries. Okay, how to generate the SQL queries, but do not depend on AI models. Okay. Initially, you may be thinking it is like quite useful, but unless that knowledge gets into your mind, you may not be able to interact with the servers and the databases easily. So don't depend on AI. So once you master SQL concepts, then yes, you can depend on AI to achieve some complex requirements. But initially, you just try to practice all these things. I'll also show you parallelly what all different types of queries that we can use. Okay, let's say I want to write these TSQL commands. Where do I need to write it? I need a platform, right? I need an application, right? There is something called IDE, Integrated Development Environment. Okay, so for every application, there has to be, if you want to code something, there has to be an interface available that we call usually IDE. Okay, Integrated Development Environment. Okay, so we have one IDE here, which is our client application, interface. Okay, there we can write our SQL codes. That client application is SSMS, SQL Server Management Studio. Okay, SSMS, SQL Server Management Studio. Okay, right. So what is our server name? Microsoft SQL Server. What is our client name? SSMS, SQL Server Management Studio. Okay, so we have a server and we have a client. Inside the client, what is it we need to do? We need to write the SQL commands, right? Which variant of SQL? Yes. T-SQL. Why we write only T-SQL? Because Microsoft SQL Server understands T-SQL. There are other variants also. But yesterday I was talking about this, right? And you get a question. You are learning T-SQL here. What if I get an opportunity to work with MySQL? No need to worry, because 95% of the commands, they look same across all these different variants of SQL. Okay. So we are working in a client and a server environment here. Server is Microsoft SQL Server. Client is SSMS, SQL Server Management Studio. And the language we are using, SQL. Which variant of SQL? It's TSQL. Right? Yeah. Online participants, any questions here? Okay, perfect then. Moving on to the next one. Let's try to understand what is this database management system. We as a client here, we sit here using our client application. Let's assume that what is our client application? SSMS, SQL Server Management Studio. So this is our client application, right? So we write a T-SQL command and we send it. And it hits the DBMS, the database management system. Okay, that's your server. The server application is SQL Server, Microsoft SQL Server. And the server can have multiple databases. Let's assume one of those databases, you are expecting some data from it, only this much part. You're not expecting entire database, okay? So what is it here? You wrote a data retrieval query. What did I write? What did you write here? You wrote something like select star from transactions where the transactions in the last 6 months. You just want to extract the last 6 months data and you trigger the query. It hits the server. Server goes to the database and it picks up the last 6 months data, whatever is there, and it brings it back onto your screen. So you can see the last 6 months data. So let me just show you practically what happens here. So the client application SSMS. Of course, you may be downloading 20.2 version. I'm using still a little older one. We'll discuss that. What is that SQL Server configuration and why am I starting or stopping the servers? I'll explain this. Right, server is now running. Let me connect. So we'll go through all these steps. Okay. So this is SSMS. This is my client application. So this is where I can write the codes. Okay. So I just want to write a query on the employee database. Here we go. I'm here and I just opened SSMS. Here we go. And I can write a query there and a query to retrieve employee table data. So I can say that select star from employee. Okay. And when I execute this, what kind of a query is it? I wrote select star from employee and I'm sending it to my server. What kind of a query is it? It's a data retrieval query. And it hits the server. What is my server? It's my SQL Server 16.0, right? Of course, the SQL Server, this is 2019 server, if I'm not wrong. So the server number is 16.0 point, some number they gave. Okay, that's my SQL Server, and the server name is KK Laptop. And in your systems also, you will install this. I'll show you the process. Okay, because for practicing purpose, you need to install both server and client. Okay, done. So I wrote select star from employee. That's a data retrieval query that goes to my database management system. And when I execute that, right, what my server did, it went into this database. Consider this is EMP database, and one of those tables is employee. That table's data is now present here. Okay, if I want to get department data, let's say department table is there, small table is there. Okay, so the same thing, I just need to write one query here. What is it? Select star from DPT. I remember the table names. Okay, you may get a question, how are you typing this select star from employee, select star from DPT? Because I know the table names there. So that's the reason I'm directly using it. So if I execute that, what it does, this time I wrote select star from DPT and I triggered that. It's a data retrieval query. It hits my server and server goes to the database and looks at the DPT table and it brings it to my system, which is here. You understand the process now, right? So all these commands I'm writing using which language? SQL. Maybe as on today, whatever I'm typing here, select star and all these things, maybe for few of you, they may be looking very, very new. But yeah, we are not into the SQL query, writing level. It will take some time. But before that, we need to go through a little bit of theory. So that's the reason I'm just showing. So I'm using my client application. What is the client application I'm using here? SSMS. And what kind of a variant of language I'm using here? T-SQL. And what is my server here? Microsoft SQL Server, right? And the server name, I renamed it to KK Laptop. And this server can have multiple databases. One server can have multiple databases. Okay.
So, like you told, it's for 2019 server. So every year there's a new server or the same server will be continuous?
No, currently it is 2022 developer server is available. So all of you will download 2022. But it's been like a long time I downloaded and I'm just still using the same 2019 server. But you have the most recent one is 2022 version. Okay. So you will download that only. So I'll share that link. Okay. Fine then. Now you understood, right? We are client using a client application. We have a server and we have a database and we are able to extract the data from there. That's it, right? As a data analyst, this is a skill that you need to have. Our job is to extract the data and use the data for the different reporting needs, right? See, this is the reason we always say that as a data analyst, there is no point learning the complete SQL development program. No, you need to just have some idea about it, but we do not, you know, need to actually learn each and everything in SQL. There is no point. Even if you learn it, you don't get any opportunity to work with it, right? Fine. What is RDBMS? It's a relational management, relational database management system based on the relationships. Okay. It's introduced by EF Code. There are 13 rules proposed by EF Code. Okay. It means the data is stored in multiple tables having the relationship between them or between the tables or among the tables using the keys and constraints. Understand this. A relational database where the data is stored in the form of tables and these tables have relationships. Multiple tables will be there. They can be related. Okay. So a database, a RTBMS that has multiple tables that can be related. Remember this way. Okay. So there are rules. The rules documentation, I already kept that here. If you are interested, you can go for it. But let me tell you one thing. You really no need to learn this EF code rules. Why? Because this is for someone who is developing a new RDBMS application. We are not here to develop anything. Okay, we are here to just extract the data and prepare the reports using that data. But we don't develop. But there are 13 rules. If you are creating any new RDBMS, your RDBMS will have to comply with those 13 rules. But of course, we are not creating any new application here, right? So that's not needed. But remember, there are 13 rules proposed by EF Code, and all these RDBMS should comply with those rules. Okay. What is relational database? The data is stored in the form of tables, and these tables have relationships. Okay. Remember that way. Fine then. So what is the advantage of any SQL database or any kind of other database? Okay, understand this. We can directly query the data and no need to scroll through the physical system. I'll tell you one thing. Let's say if I'm working with the file system like this, all these folders have what? Different files, right? If I want to pick up a particular file, what is that I need to do? You need to go to each and every folder and, let's say you need to go to that query levels and you need to pick up that file. But hold on. If you are looking for a particular employee data, if your data is located in the form of files, let's say this is employee file 1, this is second employee, third employee, fourth employee, these are employee files, okay? Each and every file has employee related information. What is employee name, employee date of birth, and all that stuff. Each and every file. But I need to scroll through a lot of files. Like say, if I have thousands of employees there, thousands of files will be there. I need to go through each and every file system, right? And if I pick up the file and I need to open and see that. But in SQL, it's not like that. Let's say if you want to get an employee data, right? You can say where EMP let's say, is equal to 1001. I can directly query that 1001 employee details simply like this. I no need to open each and every file. Okay. Just with a simple query, I can retrieve the data. Like a record, one row. In Excel, what do we call? It's a row. In SQL, we call it's a record. It's one record. Okay. So you don't need to scroll through the physical file system. We can directly query the data with simple filters, where clauses and all we can write. Another thing is controlling redundancy and inconsistency. Okay. Controlling redundancy and inconsistency. What is this redundancy and inconsistency? Let me show you one example here. All these files are there in the material. Okay, you can just go through that. Yeah. To make it a bit more easy, just take you through the two real-time systems. After that, we'll come back to these points only. Okay. So we usually see two types of systems. They are OLTP systems, OLAP systems. OLTP, online transaction processing, OLAP, online analytical processing. Okay. So as it says, T for transactions, right? A for analytical processing, right? So maybe looking at the name, which system you work with, OLTP or OLAP? I'll explain these systems, but I'm just asking you a simple question before we start here. You have two types of systems. Both of them are there to store the data. Both of them can store the data. Which system you work with? OLTPs or OLAPs? Why OLAP?
Data retrieval is
It is saying analytical processing, and we are here to analyze the data, right? So let me take you through. Okay, look at that A, that gives you some idea. If you become a data analyst, you work with the analytical systems, okay, not the transaction systems. Okay, so what are they? Why do real-time require two types of systems? Okay, in this example, I'll also include what is normalization, integrity constraints, and different things are there. Once you understand this, you will have a better idea. Understand, so far we have been talking about a database, right? These databases can be managed either using OLTPs or OLAPs. Okay. So what is the basic of OLTP? Understand that it's an online transaction system and manages the database modification. So let me give you a simple example here. If you go to a shopping mall, there is a billing counter. Okay. A billing counter is the best example of OLTP. What kind of things they take place there? The transactions that take place there, right? So understand this. You pick up a couple of products in that shopping mall. You go to the billing counter. What happens there?
barcode scan.
Barcode, perfect. They scan the barcode. That's it. Product details, they appear on the screen, and product is 1,000 rupees. Done. What's the next step?
They show the total amount.
They show the total amount, and let's say it's 1,000 rupees. Right, card or cash. Let's say you made the card payment. Okay, and swiped it. Transaction is successful. Bill gets generated. And every bill that comes with one unique identification number called either invoice number or transaction ID or order ID. Different ID numbers will be there, right? So what happened there is basically one transaction took place in that particular event, right? One transaction took place. So what is it? It's an online transaction system and manages the database modification. Understand, in the billing counter, what happens? You go to the billing counter, you give the products, they scan it, and they collect the money, and they generate the bill. One transaction took place. Okay. So that billing counter job is basically to manage the transactions, right? ATM, right? That is also a best example of OLTP. What happens there in ATM?
Insert the card first.
Right, we insert the card, we enter the PIN. Let's say we want to, do some transaction with it. Let's say we want to withdraw some money. Right, what happened there? One transaction. Have you observed? You get an ATM slip and it shows transaction ID, right? We did one transaction. So all these things, whatever the transactions that you do there, all these things basically in the real time basis, you are doing some modification inside the database. You're basically inserting a new transaction there inside the database table. Okay, so let's say if you go back to the same shopping mall and you give the bill and say that, okay, I want to return this product. So how do they track the transaction? Using that transaction ID on the bill, right? When they key in the transaction ID, it fetches all the details and they can do what? They can, okay, so if you want to exchange it or you want to take any other product, they can do that modifications there again, right? So understand that billing counter and ATM, and there are so many other OLTPs in this, we see around. I'll give you so many other examples also. But for now, understand billing systems and the ATMs are the best examples of OLTP. What happens there? The transactions take place there. What kind of things it focuses on? It focuses on insert, update, delete. These kind of commands are executed in the billing, in the OLTP. Let's go back to the billing system again. Let's say you buy something. Then what's happening there? You are inserting a new record into the database table. You're inserting a new record. Okay. Then let's say while that person is doing this transaction, that person asks like, okay, we see your email address, okay, and you find your email address which is incorrectly mentioned there. And can you ask that person to update the email address? Yeah, you tell that person, okay, or otherwise, the previous email address I'm not using, please update my email address. That person can update. So what kind of transaction happening there? It's an update statement. Okay. And then you see two addresses, they belong to you in your customer profile. When they ask your mobile number, when they typed it, you see two addresses there. One is your office address, one is your home address. And you say that, no, I'm not working there anymore. So delete that office address, but keep the home address. Can they do that? Yeah, depends on the permissions. They delete the office address and they keep only the home address there. Now you're getting it. What can happen at the billing counter? So three things most commonly we see. We insert new transactions, we update the existing data there, or we delete the existing data. Okay, most common things, right? In a billing counter, these things can happen. Let's say ATM. Okay, ATM. So you go to the ATM, you insert the card, you type the PIN, and you want to, check your balance. That is also one transaction. So in your customer log, it creates one entry, one new record. It inserts one new record, right? What it shows? It shows so-and-so customer accessed so-and-so ATM machine, so-and-so time, inquired the balance. There will be one record maintained. Each and everything is tracked. Okay, fine then. That's an insert kind of a state, right? I have a question here. You go to ATM and you withdraw the money. You have like 50,000 cash, 50,000 in the bank balance, and you withdraw 5,000 from there. What kind of a transaction is it? After withdrawing 5,000, your balance will show 45,000, the updated balance, correct? Now you tell me, what kind of a transaction is it? Is it insert kind of a transaction, update or delete? Is it insert, update, delete? Online participants, you can also try this. Is it insert, update or delete?
Insert and update.
Insert and update. It's
Like
update.
you're week 5 and the left is 45.
Hmm.
You're updating something.
We're updating. Okay. Fine. So let's say today you open your bank account and today you check your balance and so it shows 50,000. Next day, you open your account online, okay, and it shows 45,000. Okay. You're okay? Why no? So you want to know where is that 5,000?
bank account holder did not remove anything. So
Hmm.
how can it be updated to 45?
You actually you withdrew the money, okay?
So it's updated only.
But I forgot that I withdraw the money. Then,
So after withdrawing, you'll get some slip, I guess. So
right?
from that ID.
I slipped that slip. I missed it somewhere.
So we have to go to the bank,
Hmm.
tell our phone number, tell our
Hmm.
customer ID.
Hmm.
They'll track the record. Then you can get the actual
So,
slip or something.
so in the bank statement online, can't I find that 5,000 record that
Back online.
I mean, in the bank online account, when you check by logging into internet, banking, can't I check that 5,000? Can I check that?
Yes.
So understand, if your 50,000 turned to 45,000, they do not simply update it. They don't update the records, by the way. Bank transactions history, it is not updated. It is always inserted. How? If your balance is 50,000, a new record will be inserted as what? Withdrawal amount, 5,000 on the debit side, then 50,000 on the credit side is your balance actually. 5,000 will be subtracted and the final balance is 45,000. Withdrawing the money is not an update statement, is an insert statement. Of course, your balance gets updated after subtracting the withdrawal amount. But it's an insert statement. You want to see each and every withdrawal that you do, right? You cannot simply ignore that record and just simply updating the final balance. How does it leave the track? You getting it? Withdrawing money is an insert statement. It's not an update statement. Each and every record will be tracked. Okay, recorded and it will be tracked. You got the point? Right? Perfect. Let's say you want to change your PIN. Right? Existing PIN is 1234 and you want to update that PIN to 4321. What kind of a transaction is it? It's an update statement. So it overrides the existing PIN with the new PIN. It's an update statement. But along with that, it also triggers something, okay? Of course, I don't remember with ATM pins it works, but if you use any password, okay, for a banking website, okay, and it says clearly you cannot use any of the passwords that are used previously, right? That means it needs to remember the history also. So what it does in this case, it updates the current one and it also keeps a record of the previous one in some other table. Otherwise, how it can remember that, previously I used the same password. You get this point? So while updating the table, it also triggers one more insert transaction in some other table. So there is a concept called triggers also, right? So it doesn't ask you, right? Something like, let's say earlier my password was ABC123. Now I want to change it to ABC125. Now this ABC123 is to be stored somewhere, right? Why? Because when I'm trying to overwrite or replace this one or update my password, it also needs to check the previously created passwords, right? And it says like, then it compares whatever the new password I'm giving here, it compares, whether it was previously used or not. So that means it needs to update the existing one along with that the previous one to be stored in some other table so that it can go back, always go back and verify whether it's been used earlier or not. So there is something called triggers concept. We'll talk about that. Okay. But insert, update, delete. You got some point, right? Right. Okay. Okay. Metro, you use it? Yes, Hyderabad Metro. Right. Perfect. Either you can swipe your card to get inside, or you can buy a ticket and scan the QR code and you can get inside, right? Perfect. What's happening there? Every time you tap your card or you show the QR code there, what's happening there? A new record is getting inserted in the table. That so and so traveler with this card entered into Metro. okay, inside the metro station, right? Which train you took and all, that's a different story. But how that can be tracked when you again swipe, what is that? Swipe out, okay? At the time of exit. Then it records that, okay, so and so customer boarded here from the station and exited from here, right? So each and everything is tracked, and all these things are insert statements. Got the point now? Right. All these real-time transactions, whatever we are seeing, be it a metro, or be it a shopping mall, or be it a ATM, or be it any ticket booking app, or anything, all these things are OLTPs, online transaction processing. The systems, the application's job is to basically insert, update, delete, to perform insert, update, delete. Okay. So who use this system? All the data entry operators, they use the systems. The OLTPs who use all the data entry operators. Okay, billing counter, what's happening there? Data entry. ATM machine, what's happening there? Data entry. Metro station, what's happening there? Data entry. Okay, so all the data entry operators, they use OLTPs only. Oh, I get a question here. Do we also do the data entry? Are we data analysts or data entry operators? Do we do data entry or not?
Yes, but I don't know how.
Do we
Because
do?
we-
We don't do any data entry?
Yes, we do.
Where?
Mm, in database, if we want
Hmm.
to entry any data, we'll do that operation.
Mm. Okay, so we all work with the databases then? No? See, maybe if you get a job and you're working with company and let's say you want to input some data, I understand this point. But at this point, do you do any data entry?
Not sure. I'm confused.
Okay. We all are kind of data entry operators only.
Also,
Hmm. Yes. You all are thinking, we all are, what do we say? Data analysts, right? But yeah, wait, we do a lot of data entry.
by doing transactions, they like daily.
You did any GPay transaction yesterday?
Yeah.
Yeah. What did you do there? You did a data entry operation there.
That's what it's.
Yeah. You would have ordered something, a Swiggy, Zomato or something. What did you do there? You entered your own data there. Right. Earlier, it was the other way around. If you look at the banking systems and all, the way they used to work. Let's say if you want to do some transaction with the bank, what is it you need to do? You need to go to the bank, meet that person. And let's say you want to withdraw the money, you need to write a slip and you give that. And that slip, data, whatever is there, the bank employee used to enter that there into the system, right? And create a transaction there and used to give us the money, right? Someone else used to work on behalf of us. Right? Actually, both were working. We were going to the bank, and that person was taking that slip. I mean, person takes that slip and uh, enters that transaction into the system and then gives us the money. Right? After that, ATMs. Who is entering the data? Customer entering the data. Do we need the bank employee there? No need. You see the advantage of getting machines into the business. Okay. So no need. So no bank employee there. It's as a customer, you go to the ATM and you do the data entry. What is the data entry? You input the PIN, you access your account, you input the amount. All these things are data entry only, right, into the system. We do a lot of data entry every day. Every day. Let's say you register for a course. What did you do there for the registration? You enter your data, either in Google Forms or any application, right? We do a lot of data entry, right? And we access a lot of databases as well. Don't think only employees access the databases. All those transactions you are doing is basically these transactions in the backend, they are accessing the database only. You don't get any direct permissions to log on to the database and do some activity there, right? But using the front-end application, what is that you are doing? You are accessing those databases only. You book a train ticket, you access the, railways database, but of course with limited access, not the full control, okay? It's just a limited access. As a customer, we can define different types of user accesses also in our databases. Right, you access as a customer, and as a customer, what all should be visible? All the trains should be visible, dates and the tickets availability and all that basic information should be visible. And you input the data, your name and all that, and you want to book a ticket and you make the payment. What's happening there? You are doing data entry. We access all these databases, but as from the end user standpoint only we use. But once you become a data analyst, you will have to have a little elevated access, because you need to retrieve so many different tables data, and you want to prepare the reports. For that you need to directly get some access to the database at a different level, not like end user level. Okay, end users have so many restrictions, they cannot read each and every table there. But as a data analyst, your company will take care of it, okay? So they will give you the required access to extract the data from the different tables. But in reality, we all do data entry, understand that, okay? Fine then, so what all we do there? Insert, update, delete. And what kind of data it handles? And it is basically the original source of data. Whatever the data that you see inside OLTP is the original source of data, because that is where for the very first time the data gets recorded into the system. Okay, original source, nothing but if you go to the billing counter and you do one transaction, that's the very first time the transaction is entering into the system. And why we call this as original source? Because later the same data will be migrated into different other systems, or copied or cloned into different other systems. We'll talk about that in the OLAP. OLTP has short transactions. OLTP has short transactions. Okay, simple example. If you go to ATM, no one is there. How much time would you expect a transaction to complete? Let's say you want to withdraw 10,000.
Minutes. In minutes.
In minutes, maybe a couple of minutes, right? Yeah, so they are short transactions, and the processing time is comparatively less in OLTP. Just take an example of a billing counter here. If no one is there, right, how much time would it take usually? Hardly takes any 5-10 minutes, including the payment and everything is done, right? And you get a bill there, right? OLTP processing time is less because they handle short transactions, right? Simply insert, update, delete. Here in OLTP, we see simpler queries. Insert, update, delete queries are simple here. Okay. Right. These are simpler queries. I'll come to the normalization and integrity, data integrity shortly. Okay. So let's talk about OLAP now. OLAP is online data retrieving and data analysis system. This is online transaction system where it manages the database modifications. It is online data retrieving and analysis system. Okay. Why do I need a separate system for this analytical process? Okay. Simple thing. Let me explain this point and then I can ask you something. Extract data for analyzing that helps in decision making. So basically whatever the data that is stored in the OLTP that gets into OLAP, and where we extract the data, and using that data we try to analyze it. Okay. So you get a question, the data is already available here, right? Why do I need to depend on some other system? If the first system, OLTP itself, is storing all the original source of data, then why do I need to have the same data in some other system to extract it and analyze it? Can't I do it in the OLTP itself? Because the data is there here in the OLTP also, right? Consider there are two databases. The first database is taking care of insert, update, delete. The second database is taking care of only extracting the data. So basically, there is a process called ETL, extract, transform, load. ETL, extract, transform, load. There is a role called ETL developer. The job of the ETL developer gets all the data from the OLTP and load all the data, extract all the data, transform into the required shape and load it into OLAP. Right? What is the job of the ETL developer? Extract all the data from the OLTP, transform that into the required shape and load that into OLAP. You get a question, the data is already there in OLTP, then why do I need to extract it, transform it and load it in OLAP? Can't I directly treat the data from the OLTP itself? Right? Because that is the original source of the data, right? That is where all the transactions and everything is ready. Then why do I need one more system and by, creating one more role ETL and, extract the data from the OLTP, transform the data and then load it into OLAP? Can't I directly use OLTP system for my reporting needs? Here's the point. Of course, all the data is there. And what is the primary job of this OLTP? To handle all the real-time transactions, right? To handle all the real-time transactions. And what do we do there in OLTP? We insert, update, delete in OLTP, right? Let's do one small exercise to practically understand this. Online participants, you can also try this. Okay. All of you have pen and paper, right? Okay, perfect. Maybe on a rough paper, okay? You don't need a main paper for this. It's like a small exercise. Let's try to understand this, what happens. I'll give you a few tasks and you need to identify what is that you are doing there. Okay. Write 12. Write 12 on the paper. Okay. What did you do there? What kind of a statement is it? Insert. You inserted something into the table, right? What is the value you inserted? 12. Perfect. Write 18. Okay. Write 22. Okay. Fine then. What all are you doing so far? What kind of activity are you doing?
Data entry.
You are entering the data, nothing but it's an insert statement,
Hmm.
right? So I told you 18 in the second position, right? The second record. Okay, change that 18 to 16. Strike it off and put 16 there. What did you do there?
Update.
Updated it. Perfect. Updated it. So whatever the 18 value is now there as update, right? Okay, write 24. What did you do now? Right, inserted. And I told you 22, right? Yeah, in the third position. Delete it off. We don't need that. What did you do now?
Deleted.
Deleted. So insert, update, delete you are doing, right? Okay. Write 32, 38, 42, 49. Okay, tell me the sum of the first two numbers. The
28.
first two numbers that you have. And remember, you deleted one of those records there, okay? How much?
28,
How much? What all are the numbers you are doing?
12 and 16.
12 and 16.
6.
Yeah, 12 and 16. Last number I said 49. Okay, 55. Write it. 55, 61, 68. And get me the sum of second and third number.
61 and 60.
65. 61, 65. Okay. Get me the sum of second and third number. And meanwhile, write one more number, 75, 78, 79. And get me the sum of third and fourth number.
79.
Third one is deleted.
Hmm.
55.
So then third one is deleted. You identified that. Okay, get me the sum of fifth and sixth position. And while you are doing it, what is the minimum in all these numbers? What is the minimum in all these numbers, whatever the numbers that you entered?
It is, 2-digit numbers.
What is the minimum number in all these numbers? What is the minimum there?
12.
Well, yeah.
Right, okay. What is the average of all these numbers? And while you are doing that average, write 89, you're getting some point here. You're struggling. When I was giving you only that insert, update, delete statements, you're finding it okay. And you're just entering it, updating it, changing it, deleting it. But along with that, I'm also asking you a few analytical questions. Get me the average of it. What is the minimum value there? What is the maximum there? Get me the sum of the first three numbers, right? Because these are analytical questions to the system. I want to see the average sale value. I want to see the max sale value. I want to see the minimum sale value, right? When I was asking these kind of questions, you are doing what? You are playing a role of both OLTP and OLAP. You are entering, updating, deleting all those values, plus you are also trying to handle analytical questions also, right? But let me switch this exercise in a different way, okay? Into a different way. Let's say you take care of only entering the data, updating the data and all. And whatever the data it's been entered here, you just take care of only answering those analytical questions. Okay, looking at his notes. Okay, just like an example, right? He'll be entering it. Just you are doing OLTP job and you need to do what? Whatever the analytical questions I'm asking, you want to focus only on that. Okay, get me the sum, get me the average, you take care of it. And your job is only to input the data, update the data, delete the data. Would you find that a little easy to handle? Yes. Now you get it why we need two systems. Even, if you keep only one system in the real time, one system is already busy in handling a lot of real time things, right? So a simple example here. Let's say you go to the billing counter, right? The same billing counter is using what? OLTP. But your business did not implement OLAP. Let's assume OLTP is there. And all the analytical questions are also asked to the OLTP only, right? I want to find out the total sale value so far. What was yesterday's sale value? What is today's sale value? What is the comparison? What kind of percentages are differences are there, right? Only one system is handling it, right? And you go to the billing counter to buy something as a customer. And the billing executive says like the servers are slow. You hear this? It's taking some time to process, right? Could be many reasons. I'm just giving you one example here. Your server is busy. Basically, it is trying to handle multiple customers because you have your stores across India. Multiple systems are there, multiple billing systems are there, and all of them are connected to one server. And the server is trying to share the data with all these billing systems, and the billing taking time. And along with that, all the analytical questions also asked to the same server. And that is serving those things also. Okay. Now, the point is this. The customers, let's say they waited for 10 minutes, but still not happening. Waited for 15 minutes, still not happening. What happens? Customer leaves without buying it. You're getting it? So that means you can't lose the customer just because your server is slow, right? The entire servers and all that stuff have been implemented just to give a better experience to the customer, right? So just in case if your server is not responding, if customer leaves, and what is that? It's a loss to the business, right? You're getting the point. Now, what is the thing that we need to do here? For all your analytical related things, you need to have a different system. Something like one system takes care of only entering the data, nothing but generating the bills, updating them, modifying them, deleting them. The other system takes care of only analyzing the data. Now you see that. But whatever the original source is there in your OLTP system, then how it gets into OLAP? I told you one process. What is it? ETL. ETL. There are ETL developers, data engineering teams. Okay, they create the data pipelines, and from one system, it gets into some other system. Okay, they extract the data from the OLTP, they transform the data and load the data into OLAP. That is the reason different OLTP databases, they become source for the source of data for OLAP. Now you get the point? there is an advantage also by doing this. Let's say you have different databases, they are located in different locations. Like something like you have one database in Hyderabad to handle all the Hyderabad stores. That is managed by one server. You have one in Chennai, one in Bangalore, one in Delhi, one in Pune, one in Mumbai, one in Kolkata, one in Jaipur, different places, right? CEO sits in Mumbai location, wants to see what happened yesterday across India. But this data is located in different databases. So that means there should be some process to bring in all the data into a single place, right? Then only the CEO can understand what's happening in the entire India, all the stores, what's happening, right? So that means there should be a way that you need to get all the different OLTP databases data into one place, right? Called data warehouse, right? It gathers the data from different databases and keeps it in one data warehouse. One data warehouse. As a data analyst or a reporting analyst, we get the access to the data warehouse because we don't want to work with the individual OLTP databases. We want to work with a centralized data source or a central repository of all your data is called a data warehouse. Okay, we get access to the data warehouse. So you may get a question. So usually as a data analyst, do I get access to the complete data warehouse? No. Let's say you joined as a financial analyst. You should be accessing a few finance related tables. You are into marketing analytics. Okay. You should be able to access only the market related tables. Sales, only sales tables. So the data warehouse is a central repository of all the data of your company, but you don't get access to the full warehouse. You get access to a small part in the warehouse is called a data mart. It's a small subset. It's a subset of your data warehouse. Data warehouse that contains all the departments data there from all the different, OLTPs, right? But you don't get access to the full data warehouse. What is that you get? You get only a data mart access because it is a subset and which is enough to perform your role. Right? Let's say you are into financial analytics. What is that you want to do with the HR tables there? A sales tables there, right? There may be some dependency. Only those dependency, dependent tables, so you will get the access, but not every table in the other department. Get the point? Right? Yeah. So understand, OLTPs, they are the original source of data. With the help of ETL, we get all the OLTP data into OLTP. And this is where our data warehouse is present. We get the access to a data mart inside the data warehouse and using which we create the reports. Go on.
So, so we have done the transaction. After that, we have to do an analytics. So we extracted the data. Now there is a change, update, or deletion in transaction. So the data will be changed in analytics also after extraction, or we need to manually refresh it or.
Good one. Let's say this is the original source of data. This is your billing system. Okay. Customer bought something today. Okay. So during the midnight, usually the ETLs they take place during the midnight when the transactions are completely stopped. Let's say the shopping mall is closed at 10 o'clock, 11 o'clock, all the transactions are done. 12 o'clock to 1 o'clock, midnight, the ETL process takes place. What is the job of ETL developers? They need to read all the data from the different OLTPs. And there is a transaction done by one customer of 1,000 rupees that day. So that 1,000 rupees data, that record will enter into your OLAP. Next day, when you report it, the total sales is this much. You show that. Done. After 2 days, the same customer comes back saying that I did not like the product, I want to return it. And the company has a policy that if someone returns a product, and you will have to pay the cash back. I mean, the cash to be paid back. Then a sales return entry will take place, right? Sales return. And then returns data also, that will also be captured here. That is one way of handling it, right? After 2 days, when you get the data from the OLTP, there will be a sales return entry, and that return entry will also come into your OLAP, and then 1,000 rupees you got it, right? So now there is a 1,000 rupees sales returns. and both will be offset, and then you will see a zero value there for the sale value. So, but it is, creating a new record. One is a sale entry and the other one is a sales return entry. This is one thing. But the question what you asked is, what if something gets updated, which was previously, loaded into OLAP, but now that got updated in your OLT? Then how to handle this? Yeah, there is something called, in the reporting side, we call something like incremental refresh. Okay, nothing but if any update takes place, the same update will get into your OLAP as well. Okay, if a record gets modified, we check that record when it was modified. If this is falling in yesterday's time frame, we pick those records and we update them in our OLAP. This is where there are so many checkpoints come into picture while loading the data. While building the data pipelines and all, the data engineering team, they take care of this. If there is any chance that the historical data can change, okay, then they perform a different type of a load. It's not just like everyday transactions moving them. If your historical data can change, then they look at historical data also using the last date time, last updated date time. If that last updated date time is within the last 24 hours, they can pick that and they will overwrite the record inside OLAP. Otherwise, the data, consistency issues you will find, because in your data warehouse, your sale value may be showing 1,000, but in reality, the sale value is 0. You're getting the point? So there are different ways they handle, right? As a reporting analyst, you don't need to worry. Why? Because by the time the data comes to you, all these things are taken care by the data engineering teams. Okay? So even if the historical data changes, right? OLAP has long transactions. I'll tell you why. Let's go back to our restaurant example, okay? You ask the server, get me, let's say in Hyderabad, get me some biryani, okay? Chicken biryani, that's it. Right? Okay. Now tell me how much time will it take?
15 minutes.
10 minutes. Usually, it's like a already prepared one and just need to should be served. That's it, right? But this time my requirement is this. I want to get, let's say, paneer butter masala with low spice, okay, and with more paneer, okay, and it should not be so hot, okay, and it should be served in what is that? In a copper bowl, okay. You see that when I'm giving all these conditions, these are my filters, okay. These are my different kind of criteria conditions. When I give such a very specific requirement, will it take same 5-10 minutes? No, right? Understand that all the analytical kind of things, they come with so many criteria, the conditions like this. So when you're keeping so many conditions, it usually takes more time. A standard one like insert, update, delete is easy. But if you are looking for something very, very specific with this condition, that condition and all, then it will take more time. That's the reason OLAP transactions have, they are long transactions and they take more time. Because analytical queries are not as simple as insert, update, delete. You will be writing so many conditions there, so many filters there, having clause, where clauses, aggregations, different kind of window functions that we do. Okay, completing all these different things and getting you a final result will take definitely some time, right? That's the reason OLAP queries are complex queries. Okay, OLTP queries are like easy, simple insert, update, delete, 1 line, 2 line things. But OLAP things, you see like sometimes 20 line, 30 line, 40, 50, 60 lines code also, right? So that's how it is. You got some idea, right? Why 2 systems are needed, why one system is dedicatedly taking care of insert, update, delete, the other system is taking care of that only the analysis and retrieval system. You understood, right? what is data normalization and integrity? I'll discuss those points here. What is data normalization and denormalization? Why that data redundancy and controlling redundancy and inconsistency is needed. Okay, we'll talk about that. Okay, in tomorrow's session. Are you okay up to this point? Got this? So what is normalization and what is integrity? I'll talk about that. And then we'll move on to the other advantages of SQL. What is efficient memory management and indexing and things like that. All of you are okay so far? Got some idea? What is the language we are using here? TSQL. What is our server name? Server name?
Microsoft SQL.
Microsoft SQL Server. Perfect. Microsoft SQL Server. What is our client name? SS. Yeah, SSMS, SQL Server Management Studio. Right? Perfect then. So let's catch up tomorrow. Then we'll see the rest of the points. Done? Thank you.
Thank you.
Yeah, thanks everyone. Bye.